The pigeonhole principle states that, so we let P be greater than H. If P pigeons are put in H pigeonholes, then at least one pigeonhole contains more than one pigeon. So basically, ang sinasabi lang nito, kung mas marami yung pigeons natin kaysa sa pigeonhole, then we are sure that at least one pigeonhole may laman na more than one pigeon. This is the simple form of the pigeonhole principle, and it states that if n plus 1 objects are distributed into n boxes, then at least one box contains two or more of the objects. So to prove this, gagamit tayo ng proof by contradiction by letting each of the n boxes contain at most one of the objects. Okay, so sasabihin natin na, okay, at most one, pwedeng one or wala ang laman nung pigeonholes natin. Then, this implies that the total number of objects is at most n. Tama? Kasi kung merong at most one, ang lahat ng pigeonholes natin, ibig sabihin, at most n yung pigeons natin, which is a contradiction kasi sabi natin, n plus 1 yung objects natin. Therefore, the theorem is true. Observe that neither the pigeonhole principle nor its proof gives any help in finding a box that contains two or more of the objects. So, hindi niya sinasabi saan ba yung box ng laman ay dalawa or more. Sinasabi lang niya na merong nag-exist na box na ang laman ay two or more of the objects. Thus, whenever the pigeonhole principle is applied to prove the existence of an arrangement of some phenomenon, hindi niya sasabihin kung ano yung arrangement or paano i-construct yung arrangement, kundi sinasabi lang niya na meron nga talagang pigeonhole na may laman na two or more objects. Notice na itong conclusion ng pigeonhole principle, hindi siya guaranteed if we have n or fewer objects. Kasi, we may put a different object in each of the n boxes. Of course, possible naman na merong laman na dalawa or tatlo, pero hindi kasi sigurado kung meron ba talaga. Kasi pwede nga namang yung n natin or fewer, pwedeng lahat sila pumunta tig-iisa doon sa box. Okay? Pero kapag n plus 1 or more, ibig sabihin mas marami yung object natin kesa doon sa box natin, then we are sure na meron nga talagang box which will contain two or more of the objects. The pigeonhole principle asserts that no matter how we distribute n plus 1 objects among n boxes, we can never avoid putting two objects in the same box. Kasi nga, mas marami yung object natin. So, hindi talaga pwede na tig-iisa lang, kundi meron at meron talagang box which will contain two or more. We can also think of the pigeonhole principle as coloring. Let's say, meron tayo ditong 5 squares and we wish to color this with yellow, red, blue, or green. Observe that meron tayong 5 squares pero 4 lang yung kulay natin. So if we color each of the squares ng tig-isa, isang yellow, isang red, isang blue, isang green, yung pang 5 square natin, sure tayo na may mauulit na kulay. Pwedeng yellow siya, pwedeng red, pwedeng blue, or pwedeng green. Basta ang sure tayo, meron talagang mauulit na kulay. Let's have some examples for this. So first, among 13 people, at least 2 have the same birth month. Kasi nga, we have 12 months. So kung yung 12 na tao, tig-isa sila ng birthday from January to December, yung pang 13 na tao, sure tayo na meron siyang kapareho. Next, in a group of 367 people, at least 2 people have the same birthday. So we are sure kasi nga there are only 365 days in a year or 366 kapag leap year. At meron tayong sobra. So kung lahat ng 365 or 366 na tao na yon, ang birthday nila is from January 1 to December 31, So, meron tayong sobrang isa o dalawa. So, sure tayo na yung sobra na yon, meron silang ka-birthday. Next, given 27 English words, at least 2 start with the same letter. So, tama nga naman kasi there are only 26 letters in the English alphabet. So, kung yung 26 na words na yon, magkakaiba silang lahat from A to Z, yung pang 27, sure tayo na meron siyang kapareho. Lastly, in a class of 50 students who took a 40-point quiz, at least 2 received the same score. Actually, very obvious to, di ba? Kasi 40 lang yung possible scores from 1 to 40. Tapos meron kang 50 na students. So kung yung first 40 mo, ang score nila is 1 hanggang 40, yung 10 sobra, sure ka na meron silang kaparehong score. So for the next example, meron tayong para siyang problem solving. There are n married couples. How many of the 2n people must be selected to guarantee that a married couple has been selected? So meron tayong n couples dito. Siyempre, times 2 yon. So meron tayong 2n people. At ang tinatanong sa atin, ilan daw dapat na tao ang piliin natin para guaranteed na meron tayong married couple na maselect. So for our solution, let's think of boxes na pwede nating ilagay yung mga tao. Okay? So those will serve as our pigeonholes. And then, yung mga tao, yun naman yung ating pigeons. Now, selecting n plus 1 people and putting each of them in the box corresponding to the couple to which they belong, then, some boxes contains 2 people. Tama? Kasi n lang yung ating box, tapos n plus 1 yung people na pinili natin. So, sure tayo na isa sa mga box na yon contains 2 people. That is, a married couple was selected. Pero hindi naman necessarily na yung nasa loob ng box na yon, sila yung married na couple. Pero sure tayo na meron tayong napili na married couple. Hindi lang natin alam kung nasaan sila. Okay? Therefore, n plus 1 is the smallest number that will guarantee a married couple has been selected. So, meron tayong 2 ways to select these n people. Pwedeng piliin natin lahat ng husband, ipasok doon sa box. Or pwedeng piliin natin lahat ng wives, tapos ipasok doon sa box. And then, pili tayo ng isa para maging n plus 1. Okay? In this way, we have selected at least one person from each married couple. Then, we have selected exactly one person from each couple. Also, we can select n people without selecting more than one person from each married couple. Okay? So, for each married couple, pwede tayong mamili ng isa sa kanila, ipasok natin sa box, tapos doon sa mga naiwan, pili ulit tayo ng isa. So, sure tayo na yung isa na yon, meron siyang asawa doon sa mga unang napili na. We have a corollary here. Let x and y be finite sets, and f be a function mapping x to y. If x has more elements than y, then f is not 1-to-1. So, hindi siya injection. Second, if x and y have the same number of elements and f is onto, ibig sabihin, surjection siya, then f is 1-to-1. So, injection siya. And lastly, if x and y have the same number of elements and f is 1-to-1, meaning injection siya, then f is onto. Ibig sabihin, surjection siya. For the last example, let's have this. A chess master who has 11 weeks to prepare for a tournament decides to play at least one game every day. But to avoid tiring himself, he decides not to play more than 12 games during any calendar week. Now, let's show that there exists a succession of consecutive days during which the chess master will have played exactly 21 games. So for our solution, we let a sub 1 be the number of games played on the first day, a sub 2 be the total number of games played on the first and second days, a sub 3 be the total of number of games played on the first, second, and third days, and so on. Okay? Now, the sequence of numbers a sub 1, a sub 2, to a sub 77 is strictly increasing sequence since at least one game is played each day. Di ba sabi niya kanina, maglalaro daw siya ng at least one game. So, ibig sabihin, kung meron siyang games na plinay sa a sub 1 day, sa second day niya, madadagdagan yung nilaro niya. So, increasing na siya. Kasi, remember, a sub 2 here is the total of first day and second day. Up to a sub 77. If you are wondering, bakit a sub 77? Kasi di ba meron tayong 11 weeks, tapos 7 days a week. So, the last day is a sub 77. So, itong sequence na ito, we are sure that is strictly increasing siya. Moreover, a sub 1 is greater than or equal to 1. And since at most 12 games are played during any week, ibig sabihin nun, a sub 77 is less than or equal to 12 times 11. Or that is equal to 132. Hence, a sub ith, so kung ano man yun, we are sure that a sub ith is greater than or equal to 1 but less than or equal to 132. Another is the sequence of numbers a sub 1 plus 21, a sub 2 plus 21, up to a sub 77 plus 21 is also a strictly increasing sequence. So obvious na yan, alam na natin kasi na-explain na natin kanina. Ibig sabihin, a sub ith plus 21, ito yon, is greater than or equal to 22 but less than or equal to 153. Thus, each of the 154 numbers, saan galing yung 154 numbers na yan? Kasi meron tayong a sub 1 to a sub 77, we have 77 dyan, plus a sub 1 plus 21 up to a sub 77 plus 21, another 77, a total of 154 numbers. So thus, each of the 154 numbers is an integer from 1 to 153. Kasi yung a sub 1 to a sub 77 natin, from 1 to 132 siya. While that of a sub 1 plus 821 to a sub 77 plus 21 is from 22 to 153. So technically, etong a sub 1 hanggang a sub 77 plus 21 is actually from 1 to 153. But we have 154 numbers. So it follows that two of them are equal. However, no two of the numbers from a sub 1 to a sub 77 are equal. Sure tayo dyan kasi nga everyday nadadagdagan siya. And then, no two of the numbers from a sub 1 plus 21 to a sub 77 plus 21 are also equal. Kasi nga, everyday nadadagdagan din siya. Therefore, there must be an I and a J such that a sub I is equal to a sub J plus 21. Tama? So, merong something dito sa sequence na to na mag-i-equal dito sa sequence na ito. Therefore, on days J plus I, J plus 2 up to I, the chess master played a total of 21 games.